Hey there, cool. Hi, good evening, happy August. Uh, Camera's in a new place for me. I know it looks different on screen. If you've ever, if you're one of the two people who've ever hung out with me live, I got jokes tonight, and let's see what else. Excuse me, gonna be short tonight. I'm not really gonna talk too much about design as far as like 3D modeling or anything else. I'm not going to give away any hints. I'm not going to do anything crazy, but we have a special design challenge. I'm changing things up this month, and I'm super excited about it. So I'm gonna give a little bit of background about the contest, where you can find out how to get involved. And then I'm going to get into what makes this different. And basically, here's my elevator pitch. Here's my chat, my information for everyone, and it starts with the Lift and Shift Foundation. I'm the founder. I'm an Army veteran. I'm an engineer. I do a lot of making things. I love to build things. I tell people that all the time. And just making sure our mic's on after I've finished 90 seconds of blabbering. But yeah, I like to build things. I like to make things. I find the process fascinating, and that really applies to anything you could think of. If you're trying to build a story, there's a process to building a story. If you're trying to build an app, there's a process to building an app. If you're trying to build a Lego castle, there's a process to building a Lego castle. All of these things are creative, and that's my fascination with engineering is much less about the math behind it, because that's boring, but the creation and the development and the ideation, the way the brain works to pop up all these ideas, and how we can all run to different corners and brainstorm and come back with something completely different. I'm super fascinated by that, the psychology behind engineering. And just a little bit about me, but I like to encourage people to get involved through these design challenges, and we have every month on our website. You can go and find out what's going on this month on our resources tab. So I'm gonna quickly pop up. Let's see, am I gonna do this right? Dun, dun, dun. Not the webcam, not that. Window capture. Oh, poof! Ding, ding, ding! There is Tinkercad. That means my browser is visible. So I'm gonna open up a new thing. I'm going to type in weliftandshift.org very quickly, take us to the website for our foundation. You can see my goofy face right there, I think, and here's the menu on the side. If you're on a phone, you can still get there. I think the menu switches to the top, and depending on what device you have, you might not be able to see the shop button, but that's cool anyway. So if you wander to the resources tab, one of the first things you can find right here is this month at Lift and Shift. Follow along with our current events. If you click on this button, it will take you to this month's events. What's going on this month for us? And there's usually a funny graphic, something fancy here, and a blurb about the month, and then we get right into the contests. Down here further on the page are resources for the rest of the month. If you want to hop into a workshop, if you want to do something one-on-one with me, these are small groups. I try to organize this so that I can manage better interpersonal connections. So if you've joined me for a Zoom with some of my favorite VSOs, veteran service organizations, if you've seen some of these workshops where there's 40, 50 people in them, that's super cool. I love to meet people and share in big groups, and that gets a bit wieldy to manage. But if you've seen that, you've also seen that it turns into more of a webinar where I can't interact with people so much. It's more of, I want to show you how to do stuff. I want to show you what you are capable of doing if you know about this free resource here or there, or whatever the case may be. And it's part of my outreach, online here while we've been locked down in Virusville for a bit. But it's a better learning environment if you want to log into one of these Zoom workshops, in a handful of us. Just, I try to keep it down to 5 or less. I don't mind enlarging it to about a dozen, but if we do that, then I need to bring on more volunteers and more people to help assist with that, because I want to make sure nobody gets left behind, because that's the opposite of encouraging. That feels discouraging. That feels like I don't want to do this anymore. And that's not the environment that I try to reinforce. So, excuse me. If you see these workshops, you can feel free to hop in. You can sign up. It'll drop an email in our message box, and somebody will send you an invite. Usually that's me, but we may have some edits through the next few months as things shift and people start going back to offices and workspaces and all that other stuff. But for the most part, yeah, hop in, please, and join us. Sign up if you have not already. Mash this little button right here and tell us you are a veteran and sign up, and you will get an email once a month that reminds you that there's a new contest and there's a new set of workshops, that kind of stuff. There's more stuff for you to do to get involved, because all of this, whether you're learning math to be an engineer, or recipes to be a culinary artist, because culinary science is a real thing in STEM, or whether you're learning Photoshop because you're going to be a graphic artist, all of these things require contact time. That's the one thing that I will say as an engineer, that I spent a lot of time in class doing math, and it was necessary to be familiar and comfortable with it. As far as math's concerned, I tell people that math is just like another foreign language. A, it's a perishable skill. You can forget things, and B, you really can't just do math. You have to talk math. You have to be able to talk to the other nerds about math, and you have to be able to to use the words they use and describe things with their descriptors, to be able to share ideas back and forth. Sometimes it's as simple as writing on a piece of paper 2 + 2 = 4, but yeah, it's contact time. This is all about contact time, and I encourage people to come back. I will never discourage people from, hey, you've done this workshop every month for the last 6 months. How about you give it a rest? That you will not find that from me. I thoroughly believe that if you keep coming back and you want more hands-on, we can find a way to make it better for everyone. So keep showing up, keep doing things, keep coming back. And on that note, I'm gonna scroll up here for just a tiny bit, and I'm gonna discuss all the August design contests. August is back to school time. Soon you'll be getting new school clothes, new shoes, a backpack, and all that cool stuff. You'll be going to some big store to pick up a pencil box and all kinds of other neat little things so that you can do your school stuff. And maybe it's not you. Maybe you're buying it for your kids. I've been on both sides of it. It's a real thing. It happens, and it's kind of overwhelming and fun all at the same time, right? But I thought the funnest way, is that a word? That's the right word, right? I'm such a terrible grammar person. I'm bad at math and English. But so I thought the funnest way to start a contest at the end of summer would be something back to school related. And I don't think people realize that you can design your own pencil grip, and I can 3D print it for you. So that's the contest for this month, and that's what we're going to spend the rest of the time talking about. And people see prints, and if you've done any 3D printing, you've probably used one very hard substrate called PLA, polylactic acid. You've probably printed things that feel like, they don't feel like a grip. They feel rough, hard pieces of plastic. And some 3D printers are very, very adaptable. They can print very many types of plastic. Yeah, that's the words I'm looking for today. Yeah, so they can print a variety of plastics. And I'm not going to get into the mechanics of the 3D printer or anything like that, but today I wanted to take some time and actually discuss how this process is going to work, and what a 3D printed pencil grip would look like. So without further ado, I'm going to slide away my monitor here, my window here for just a minute. Where's it go? Where's it go? Window. Is this the right one? Ah, yep. Okay, cool. Yeah, there we go. And I have a variety here on my desk of different types of material. So the first thing I'm going to share is this is the little string of filament. It looks like a string. It's a thin rod, almost of plastic. It's called, this one is PLA, polylactic acid. This feeds into my printer, and it goes down into this fancy super tiny hot glue gun, and it basically melts it and makes it out into like a line, and just like a hot glue gun. It's the best way to describe it. But this is the material. You can see it. It's very hard, very rigid. If you've been in any of my workshops, or if you've seen people on YouTube or anywhere else 3D printing things, you get a hard object. You get something hard out of it. In fact, here is a test model, a very popular test model called a Benchy. One of our design team actually threw this at me as a way to test 3D printers and things. You can see this is a hard plastic though. This is the same PLA. It's blue instead of gray, and it's hard. Like, you probably hear that clicking on my knuckles as I'm smashing. In fact, I want to see. Yeah, you can hear that. Cool. But yeah, so this is hard. This is a hard plastic. It's a PLA. It's polylactic acid. It's well, I'll get into numbers in a minute, because this is just one type of plastic. It's very common. It is technically biodegradable, but not really. I think it takes something like 80 years, and I would recommend recycling over throwing it in your compost bin for that reason alone, because it takes forever. If you were to put it in your compost bin, there are resources, there are other things you can put in your compost bin to help this decompose, but it technically is biodegradable. And that's just one thing. I dropped my test filament here, so I'm gonna just dive down, pick it back up. I like to wrap this up a little bit like this, so that these crazy things don't go flying everywhere. Here's another type of material. This is ABS. Acetyl I can't remember the chemical name, but it's these are basically just different types of plastics, different types of chemical makeups. ABS is a common plastic used in automobiles. Your bumper is probably made out of ABS. It's plastic. It's the same hard structure like PLA, but it's slightly more flexible, like almost like nylon. So it will bend, and that's why you see on bumpers, you can see your bumper will bend in and pop back out, because this has a flex to it. So it's still hard, but there's a slightly more flex to it when it's in a thinner sheet as opposed to a thicker block like this PLA. And neither of those are suitable for a pencil grip. I mean, if you had a material like this for a pencil grip, it just feels like poo, right? It's very hard. I'm not like flexing it. It's not going anywhere. It's awkward, hard. There's the typical pencil grip I'm used to when I was a kid felt like foam. So I have one last piece of material here, and it's another little filament string. This is this same size filament as the ABS, as the PLA, goes in the same printer, and this has the consistency of a Twizzler. If you've ever had Twizzlers, this is exactly what I think of when I see this stuff. I think Twizzlers. I'm not going to eat it, but this is called TPU is the acronym we use for it. It's another type of plastic. TPU stands for thermoplastic polyurethane, and it is very, very, very flexible. It not only bend flex, but also compression is the engineering term. Compression and tension. Yeah, it's been a while since my engineering mechanics classes, but yeah, those are the two terms for this kind of stuff. So this is actually what I will be printing this pencil grip out of. And this is the cool part, is that people who make the pencil grip, we're gonna judge the designs and ship off pencil grips to the winner. And that's super cool, right? So if you are going back to shopping, if you are doing things and you want to spend some time with your kids, maybe you want to talk about school, you want to find a way to open the door to have those conversations, or maybe as a joke with your parents who may be giving you a stipend or something. Help me. I'm poor. I'm designing my own pencil grips. Maybe you could help a brother out, kind of thing. But yes, that is what's going to happen. And just to show the material, I printed this for another project quite a while ago. But this is something I printed in my own 3D printer. It's a flat sheet of TPU basically, and you can see the flex in it. It bends and things like this. I could probably wrap it like this and make it look like a pencil grip, but it's very flexible. It's very you can compress it. If I do that, you can see my fingers make the impression in it, and that's the differences in the materials. I said earlier I would come back to this part about numbers because I don't want to give everybody the impression that you can just haphazardly throw these different types of plastic in a 3D printer. So the deal is this: they all melt at a different temperature. So you can't just pop out this gray PLA and pop in this white ABS and expect to do the same kind of printing. These have different chemical makeups, which means they have different melting points and boiling points, just like water and alcohol, like rubbing alcohol. Water will freeze at 32 degrees, so if you fill an ice tray up, half of it with ice and half of it with rubbing alcohol and put it in the freezer, the half that is ice will freeze, the half that is rubbing alcohol will not freeze, because the rubbing alcohol lowers the, changes a lot of stuff, but because you're probably not going to get pure ethanol, you're going to find a water mix, so it's going to lower the boiling point, the freezing point, and all that other stuff. I think it might raise the boiling point and lower the... No, I don't know. That's a chemistry nerd stuff question. But in any case, back to the point. These have different settings on printers and things. This is recommended to melt between 180 and 200 degrees Celsius, and it needs a hot surface or something to adhere to as far as the build plate and the build environment on the printer. This ABS, it works at a much hotter temperature in the I'm going to say 260-ish range, 270, somewhere around over 250, I think, is the a safe number to say on this stream, for example. But yeah, this and it I don't remember if this needs a heated bed element to adhere, or some type of, you know, like double-sided tape to stick down or something. But in the case of our friendly little thermoplastic polyurethane here, it needs to melt at over 200 degrees. So instead of the 200 degrees from the PLA, this works best. In my printer, it works at I think like 218 degrees Celsius. And I turn all of the heaters off for everything else. It does not need a heated bed. It does not need anything to adhere extra on the the build envelope that I have for my printer. So the point of rattling off all these numbers right now is to kind of get back into this encouraging you or anybody who may be paying attention that 3D printing is not just like a plug and play thing. It's not like your printer that you just plug in, your inkjet printer, your HP, and all of a sudden, the ink cartridge is lined up. There's a lot of other settings that go into this, and I'm not saying it's hard, I'm not saying it's complicated, but what I am saying is if you buy a 3D printer and you get involved in it, don't watch this stream and run out and spend a lot of money on a bunch of different materials, because if you don't know what you're doing with it, it's going to complicate things. It's going to make things a lot harder. My recommendation to novice, introductory type, I'm still a beginner at this whole 3D printing, is stick with PLA, because it's the most common material. In fact, your printer probably will come with a sample roll of this PLA, and learn how to print with that first, because all of these other plastics that I'm working with here, everything from ABS to PETG to TPU to tough PLA to the regular PLA. I mean, that's 5 different chemicals to have to kind of juggle all these numbers and all these settings and worry about how which one cools faster or slower or needs, a dual layer of an iron setting somewhere in a slicer. If, for example, PVA doesn't print well in these thin lines the same way that this other material does, I struggle with PVA myself, which was just something I'm not even going to talk about or share right now, because it kind of mystifies me a bit, to be honest. Yeah, I said it there. It happened. But I'm not perfect. I don't touch it too often. I've printed 4 things with it, I think, in the last year. So yeah, but that's my point is, don't go running out to the store, spending a lot of money on all this stuff, thinking you're gonna do magical things, unless you feel comfortable with your printer and PLA and all of the basic techniques of learning how to manipulate your objects to accommodate for overhangs and spaces, holes, support structures, all that other stuff that goes along with learning how to be a good 3D printer and using the software. So that's my little soapbox. That's my little 5-minute hail. This stuff is super cool, but I've been printing with this stuff for the last 6 months. I've got literally boxes and boxes of gear that I printed with it. Everything from, oh my gosh, I don't even know. In fact, I will briefly, this is a massage roller that I printed myself out of different types of PLA. Excuse me. This is another version of that. It's loud because it's coming apart. It was a draft model. Obviously what looks like a little mouse pad, a mini mouse pad, because it's flexible. Yeah, but I think that's the end of this chat about the materials, and I'm going to take the last 5 minutes before I go, and I'm going to hop back into Tinkercad, because the contest for this month, and I'm going to do this again in probably another Twitch stream next week, but the contest for this month, excuse me, is to design your own pencil grip. And I'm going to give some hints right now on how to do that. How would you even do that? What would a pencil grip even look like? So I'm gonna do my own quick pencil grip. So I'm gonna bring out my browser. Just popping out Chrome again. In fact, we're gonna go big for Chrome. How about this? Let's go big for Chrome. Poof! Shift screens. Let's go back to Chrome. This is a model of an old challenge coin that we were using in a workshop for veterans. Just to briefly, this is actually like a challenge coin. It's about a 3-inch disc with this pentagon shape on it and a star, and on the bottom another star that we printed This was a design where I taught a large group of veterans how to use Tinkercad. But let's actually grab this stuff and drag it off the screen just for right now, because I don't want to be distracted by it, and I don't know if I'm tossing this model out yet or not. But here is Tinkercad. If you get into it, I'm not going to give you like the lowdown. There are other things you can use. I'm a very big advocate for Tinkercad because A, because it's free, and B, because it's designed so that you can do a lot of things in here without having to learn how to manipulate objects. There's a much larger learning curve for Fusion 360, for the rest of the Autodesk products, SolidWorks, SketchUp. Oh my gosh, I could go on and on for all the CAD software. But here, if you open up a new workspace, you have the toolbox on this side, and I'm just gonna run through the toolbox. In the toolbox, there is this basic shapes, there are characters, connectors, all kinds of stuff. Then there's this make at home thing. And dun dun dun, there are pre-built models right here. Right here in Tinkercad. So I actually have a pencil right here. Check it out. So what I can do is I can go back to my basic shapes, and I can do something like grab this cylinder right here, drag it up. Let's do like 30. And I'm going to make it, let's make it 15 by 15 very quickly. Cool. Now I'm going to center these together. Align them like that. And I'm going to drag this bad boy up some, just like that. Just like, so it looks like a pencil grip right there, right? Cool. It's a bit chunky, and I'm doing this very fast because my goal here is I'm not showing anyone how to make their own pencil grip. I'm only showing you how to get the shape, how to get the structure, how you do this. If you use this model, I will probably heckle you. But here's what you do. You turn the pencil into a void or a hole so that it's empty space inside there, just like that. And then you combine these shapes. Oh yeah, group right there. And ta-da! Now I've got this pencil grip shape. And there it is. Now I can start designing with this, and I can start making it the pencil grip I want. And maybe I wanted a different shape. Maybe I want to go back and take out the pencil. Maybe I don't want this thing. Maybe I want to design my own funky shape. Who knows? But the point is that do not. See, I'm gonna smooth it out now. In fact, what I am gonna do, check this out. I am gonna measure the size of this. I'm gonna cheat. 749. So I'm gonna make this 745 by 745. Oh, I'm going to be so clever and cheat. Now I've made my own round pencil, the same size, and now I'm going to make that the hole. Check this out. So instead you saw, let's do this number. Go back to what I was doing there. Combine those. Lift that up. We'll do the same alignment right here. And combine those. Now you can see one is round and one has got this crazy pencil shape in it. I don't care which one you do. It may be best if this may not fit. I'm not sure, depending on pencil. I would probably have to try it myself. So I don't know if I trust this model to be accurate, because I just kind of guessed on a size. But those are two different ideas for ways you can get your pencil grip. base shape, and then you can do whatever you want to it. Or like I said, you can create. I'm going to go all the way back to the end. I mean, you can create something crazy. Yeah, I mean, you can make a set of spheres. Ready? Watch this. Like that. And then use that as the shape. I'm gonna stop now because I'm starting to give ideas, and this is what I didn't want to do, is give everybody, give anybody an unfair advantage by creeping in here and checking it out. But yeah. So those are just some ideas. I'm gonna get out of my fancy view there. Snap, we're back. And I will leave with this note. You can find this by going back to weliftandshift.org right here. Click on resources, click on this month, and it will bring you to our August events and contests and challenges. So there it is. That's it. I'm done. I think I went over the time I allotted for myself to begin with, but that's cool. I will make sure to point this out, that it's here, that it's available, that it's around. Hope it helps somebody. Hope you take advantage of the contest and design something cool so I can print it and send it to you. How about that? And next month, I think we start getting into crazier designs. Cooler designs, but crazier. Yeah, so looking forward to that. All right. Don't do anything crazy this weekend. If you're out exercising, drink water. If you're out, be safe. Don't go coughing on people. Don't go spreading crazy diseases. Drink water if you're out drinking. Any of the above. Cool.